Hi everyone, my name is Emily Little and I work for RTE, the French Transmission System Operator, and I'm going to present our model Atlas. So Atlas was originated with a European project in the early 2010s. It was originally called Optimate, and it was kind of conceived to give a complementary vision to sort of perfect foresight central dispatch models. The goal is to have sort of a realistic simulation of what happens between day ahead and real time, to give a good idea of the operation of the system, especially for prospective studies. So we do this by looking at three particular aspects. The first would be agent behavior. So we have different breakdowns of potential market actors. So we have different market area breakdowns, and portfolios that can own several assets and optimize across these asset portfolios. We also take into account uncertainty evolution. So for this, we have different forecast horizons. So depending on whether we're modeling a day-ahead phase or a real-time phase, we'll have a different forecast with a different forecast error compared to the real-time. And we also have different time granularity. So we have an interpolation model that will translate dispatch plans with a 1-hour time step to 15-minute time step. We also model quite finely the operational constraints, so both the technical constraints of our units. So this, for instance, shows the different unit technical constraints for our thermal operating, for our thermal units. So we model even minimum stable power duration, which is not included in many models. But we also model the different process constraints. So for instance, actors will have to translate their technical constraints into a set of order blocks with specific links between their orders. So here we follow the different markets that exist actually, that are actually in place. So similar to euphemia or tear, depending on which phase we're looking at. So when we run an Atlas simulation, if we're going to model, for instance, the day-ahead market, the first step is to perform a forecast. So this will give us our forecast of renewable generation, load, but also it will give a price forecast, which the actors will then use in the second phase to create their market orders. Following this order formulation phase, we have a market clearing where we take all of the orders, we maximize the social welfare according to the different constraints, and we get out the accepted orders for each unit. And following that, there's a portfolio optimization phase where each portfolio will reduce its system costs as much as possible given what was accepted in the market clearing. We'll then model one or more intraday markets, depending on the type of study we're looking at. And then we'll also model the different balancing phases. In this phase, we don't include a portfolio optimization phase because we're already in the operational window. So the transmission system operator sort of has the main control over the dispatch at this point. So that sort of describes the whole model. Currently, Atlas is not open source, but we're working on making it open source in the next year, hopefully. And we just have published 2 working papers that describe in quite a lot of detail the different optimization models at each of these different phases. So if you have any questions, feel free to come talk to me.